Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a flat specimen for tensile test. We will use steel as the material. We will start by double-clicking on Explicit Dynamics. We'll first go to Engineering Data and double-click. Engineering Data Sources. We'll double-click on Explicit Materials. Here we'll choose steel as the material 4340. I'll bookmark here. If you want to see the material, just click on Engineering Data Sources again. And here you can see steel 4340 has been added. We go to Project and Update Project. Next, I'll go to Geometry and right click. New Design Modeler Geometry. I'll go to Units, Millimeter, XY Plane, Look at. I'll go to Sketching and choose the line option. I'll draw a vertical line first, then a horizontal one, then an inclined one, a horizontal one, an inclined one, horizontal, vertical. Here again we'll draw horizontal, then an inclined one. We'll actually repeat the geometry above and below. Then we'll join here. Now I'll use the trim option to remove this extra line. Then I'll go to dimension and give dimension to these lines individually. This is 30. H3 is also 30. H6 is 30. And H7 is 30. B1 I'll give as 25. B5 is 25. Next I'll give the dimension between this line and this one. L8 will be 12.5 because it is half. Then I'll give between this line and this one. Again it is 12.5. Next I'll give H4. This is 100. Now above and below both should be 100. So I'll just undo this for some time. I'll also give this dimension. H10 is 100. Okay, it's difficult to move this before. So what we'll do is, we will give these dimensions also. I'll give this dimension. Both are 6. Now I'll give this horizontal dimension here. This one. Okay, it says over constraint, which means these two have taken the same relation. So you can just write here undo. Then this one is 10. H14 is 10. H15 is also 10. Now I'll try giving this again. This is 100. And this is 100. So you can see here I was able to give all the dimensions. Also I'll give here fillet. So I'll go to modify, click on fillet. I'll give this value as 15 mm and I'll select these two lines. So you can see here it is given. Then you can click on rest of the lines one by one together such that the fillet is created. So this is the flat specimen we were trying to create. Now we will extrude this. So I'll go to modeling, select extrude, select the sketch one, apply. The thickness will be 5 mm and generate. So this is the specimen that we are going to analyze. Once the geometry is created, we'll close this. We'll go to model and double click. First we'll go to geometry and change the material of the solid to steel 4340. Then I'll go to mesh. Units is millimeter, so I'll give the default size itself and I'll just generate. Now you can see here the meshing is not very fine. So I'll just right click here and insert method. What you can do is you can reduce the size of the mesh. I am not changing it further. I'll change the type to tetrahedrons to make the mesh to a different format of this form. Then I'll go to Explicit Dynamics. I'll give the analysis settings time as 0.001 second. I'll right click here and insert fix support at one end, that is over here. I'll select face option. I'll select this side, this one, apply. Then I'll hold the body like this. And on this end, I'll right click and insert displacement. Direction is along the x-axis as the body is inclined. So here I'll give the value as 50 mm. Then I'll go to solution and right click and insert deformation total. I also want to see the stress equivalent. I want to see the strain plastic. I'll go to solution and solve. So let's see the solution. We'll first go to equivalent stress. You can see here, this is the graph of stress versus time. You can see the maximum amount of stress generated is over here and then slowly it is going to reduce. So this is the ultimate stress at this point. This is the elastic limit, the inclined line which you can see. This is the elastic limit over here, maximum value, and then finally there is a failure, after which there is a fall. So we will just animate and see this result. The maximum value of stress generated is 1217 megapascal over this body. So you can see the breaking of this flat specimen subjected to a displacement of 50 mm. Also you can see here, this is the strain value 1.412. This is the maximum strain generated over the body, which is at this portion. You can also see necking and breaking of the specimen. The maximum deformation is given as 50 mm. So you can just see that, which will be over here, and this is the fixed end, so you see minimum deformation. Now deformation is not a result which is expected, but I just clicked it for you to see what is the deformation in case you want to know. We have already given the displacement, which is nothing but the total deformation which is acting on the body. So that's how you analyze this flat specimen for tensile test with the material steel. We will also see the analysis of this material using a composite material in the next session. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.